Okay, so on this example, it says a spherical snowball is melting in such a way that its radius is decreasing at a rate of 0.2 centimeters per minute. At what rate is the volume of the snowball decreasing when the radius is 9 centimeters? Note the answer is a positive number. So it wants us to give a positive number because it's the rate of decreasing. So the snowball is shrinking. So, okay. So we have a spherical, and they give us a hint down here. The volume of a sphere is that form. So there's the volume of a sphere. A sphere is a ball, like a basketball or something, or any ball is a sphere. So maybe I don't know. Anytime I try to draw something, it's pretty lame. See, I got kind of weird at the end. Oh boy, I don't know. But it's about that might be all we get. All she's got there. Yep. It starts working, then I get off track. Can you picture that? It's like a ball. That's as good as I can do. All right, so we got a ball, a sphere. So a sphere is a ball, and the volume of a sphere form is given there. All right, well, we can tell that what are they asking for? They say they want a rate. At what rate is the volume decreasing? So they want us to take d dt, d dt of both sides, because we got to get dv dt, the change in the volume over time, right? The rate the volume is decreasing. So I'm going to take the derivative, implicitly of both sides. So, okay, so the 4/3 will just stay in the front and the pi. 4/3 pi, that's all just numbers. The 3 comes in, the r is the variable. 3 comes down, make it subtract 1 from r squared times dr dt, right? Implicitly, we gotta take the derivative of the letter at the end there. So, okay. It tells us that the radius is 9. So we'll put that in as 9. So this will equal 4/3 pi times 3 times 9 squared, or I'll keep it with the calc, times dr dt. What's that? Well, it says right here, the radius is decreasing at a rate of zero point 0.2. So the radius, 0.2, but it's well, it's decreasing, but that's all right. It is negative. Technically, it's negative because it's decreasing, but they're asking us in the end. Well, I mean, technically, we should make it negative because it's decreasing. So, all right. So then we hit the buttons on our calculator. What we're going to get is negative 203.5752, like that. But we're going to put in the positive answer, right? It says right here, the answer is positive because they ask us. So that means it's decreasing because it's negative. It's decreasing at 203.5752. Does that make sense? All negatives are is the opposite. So so the rate of change, I know that might be confusing. So it says the dv dt, the change in volume over time is down 203 cubic centimeters every minute, which means it's decreasing at 203 cubic centimeters every minute, right? Because they asked what is the rate of decreasing? So we just give them that answer. We don't give them negative. That'd be like if somebody said, "Hey, the temperature." Yeah, let me give you an example. What the temperature dropped. It was getting colder and colder outside. It dropped from 30 to 20. And if somebody said, "How much did it drop by?" -10. Well, I mean, yeah, it's kind of weird. It went down 10 for sure. I mean, for sure, the temperature went down 10. But how do we communicate? We'd say it dropped 10, right? It decreased. You don't say the negative again. That's why the answer is just positive. So there we go.